When you were a child, did you ever press your hands against a wall and push? Just to see if it would move? Just to test the boundary? I did. I remember the feeling. The absolute solidity of it. The certainty that this was where things ended. Where my room stopped being my room and became something else. A hallway. Another world. The wall was the answer to a question I didn't know how to ask yet. Where does this space stop being this space? Now imagine there's no wall. Imagine you walk forward, and forward, and forward, and there's never a moment where something says stop. No barrier. No edge. No place where the floor becomes something else or the air runs out. Just more. Always more. Endlessly more. That's not comforting. That's terrifying. And that might be the universe. No edge. No wall. No boundary where space stops and something else begins. Just space, extending in every direction, possibly forever, possibly without end, possibly without meaning to the question how far. But here's what keeps me awake. We don't actually know. Despite all our telescopes and equations and centuries of looking up, we genuinely do not know if the universe has an edge. We don't know if there's a place where it stops. We don't know what would even be there if it did stop. And the more we learn, the stranger the possibilities become. Tonight, I want to take you to that edge. Or to the idea of that edge. Or to the place where the question itself starts to fall apart. Because asking where is the edge of the universe is like asking what happened before time began. The question assumes something that might not be true. It assumes edges exist. That boundaries are real. That where means something when you're talking about everything that exists. Maybe it does. Maybe it doesn't. Let's find out. Here's what we know for certain. The observable universe has a boundary. Not a wall, exactly. More like a horizon. A limit to how far we can see. Light travels at a finite speed. 186,000 miles per second. Fast, yes, but not infinite. And the universe has only existed for a finite amount of time. About 13.8 billion years. So light has only had 13.8 billion years to travel toward us from distant objects. Which means there's a sphere around us, around Earth, around every point in space, where the light from anything beyond that sphere simply hasn't had time to reach us yet. That sphere is called the observable universe. Its radius is about 4 to 6 billion light-years in every direction. Not 13.8 billion. 4 to 6 billion. Because the universe has been expanding while the light was traveling, stretching the distance between us and the objects that emitted that light. So the edge of the observable universe isn't a place. It's a time limit. It's the farthest point from which light has had time to reach us since the beginning. But that's just what we can see. That's not the universe. That's our view of the universe. There's a difference. Think of it like standing in a field on a foggy morning. You can see maybe 100 feet in every direction before the fog makes everything invisible. That's your observable field. But the field doesn't end there. It keeps going. There are trees and streams and hills beyond your view, existing perfectly well without you seeing them. The fog is doing what time does in cosmology. It's limiting your information, not the reality. So the real question isn't where is the edge of the observable universe. The real question is, where is the edge of the actual universe? The whole thing. The part we can't see. And that's where things get uncomfortable. Because there are 3 possibilities. Only 3. And all of them break your brain in different ways. Possibility 1. The universe is infinite. It has no edge because it never ends. Space just goes on forever in all directions. No boundary. No wall. No place where it stops. Possibility 2. The universe is finite but unbounded. It has a limited size, but it curves back on itself, like the surface of a sphere. You could travel in a straight line forever and never hit an edge because you'd eventually come back to where you started. Possibility 3. The universe is finite and has an edge. Somewhere out there, space just stops. And beyond that stopping point is something else. Or nothing else. Or a concept we don't have words for. Let's examine each one. Slowly. Because they're all deeply weird. Infinite universe. No edge. Space extending forever. This is the one that sounds simple until you actually think about it. Forever is not a big number. It's not even a number. It's the absence of limit. And our brains didn't evolve to handle that. If the universe is infinite, then everything that can happen, happens. Not metaphorically. Literally. An infinite universe contains infinite space, which means infinite opportunities for matter and energy to arrange themselves in every possible configuration. There are only so many ways atoms can be arranged in a given volume of space. A huge number, yes, but finite. So in an infinite universe, every possible arrangement happens not just once, but infinitely many times. Which means somewhere out there, infinitely far away, there's another Earth. Identical to this one. Down to the atom. With another you, reading these exact words, thinking these exact thoughts. And another version where you made a different choice this morning. And another where you don't exist. And another where Earth never formed. And another where the laws of physics are slightly different and nothing like our world exists at all. Except wait, no, if the universe is truly infinite and the laws of physics are the same everywhere, then that last one doesn't work. The laws would have to be the same. Which means only arrangements of matter differ, not fundamental constants. Unless there are multiple infinities. Unless our universe is just one bubble in an infinite multiverse, each with different laws. But now we're getting ahead of ourselves. The point is, infinity is disturbing. It removes uniqueness. It makes everything that happens not special, because it's happening infinite times elsewhere. Your life, your choices, your suffering and joy, all of it repeated, endlessly, across infinite space. Does that make it meaningless? Or does it make meaning something other than uniqueness? I don't know. But I know it makes me feel small in a way that's hard to sit with. Now, possibility 2. Finite but unbounded. This is the elegant one. The one Einstein would have liked. The one where geometry saves us from infinity. Imagine you're an ant walking on the surface of a basketball. The surface is finite, it has a specific area you could measure. But there's no edge. You could walk in any direction, in a perfectly straight line, and you'd never fall off. You'd never hit a boundary. You'd just eventually come back to where you started. The surface of the basketball is two-dimensional, curved through a third dimension. You, the ant, only experience 2 dimensions. You don't see the curvature. You just experience it as no edge. Now take that concept and add a dimension. Our universe might be 3-dimensional space curved through a 4th spatial dimension we can't perceive. Finite in size. But no edges. No boundaries. Just curvature. If you could travel in a straight line long enough, billions upon billions of light years, you might eventually see the back of your own head. Or at least, the light from the back of your head, emitted billions of years ago, having circled the universe. Mathematicians call this a closed universe. It has a specific volume. A finite amount of space. But that space loops back on itself. The problem? We've measured the universe. We've looked at the cosmic microwave background radiation, the afterglow of the Big Bang, and studied its patterns. And the data suggests the universe is flat. Not curved. Flat. Which would mean it's not closed. Which would mean it either extends infinitely, or we're missing something. Maybe the universe is curved, but on a scale so large we can't detect it yet. Maybe we're measuring the curvature of a basketball, but with the size of bacteria, and to us, the surface looks perfectly flat. It's possible. But right now, the evidence points toward flatness. Which brings us uncomfortably close to possibility 1. Infinity. Unless there's a third option. Possibility 3. The universe has an edge. This is the one nobody wants to think about. Because it requires something to be beyond the edge. And what could that even be? Not space. Space is what the universe is made of. If you're beyond the edge of space, you're not in a place. You're in a not place. A nowhere. Some physicists have tried to imagine this. They talk about nothing as if it's a thing. But nothing isn't a thing. It's the absence of things. The absence of space, time, matter, energy, quantum fields, virtual particles, potential, everything. Can nothing exist? Can there be a region of not space adjacent to space? Your intuition says yes. Of course there can. Space is something, so there must be places where space isn't. But general relativity says no. Space isn't a container that things exist in. Space is a thing itself. A dynamic, flexible thing that bends and stretches and vibrates. Asking what's beyond space is like asking what's north of the North Pole. The question assumes a direction that doesn't exist. At the North Pole, north stops meaning anything. Every direction is south. There is no north of the North Pole. The concept breaks. Maybe beyond the universe breaks the same way. But maybe it doesn't. Maybe there is an edge. And maybe beyond that edge is something we don't have the physics to describe yet. Some pre-spatial condition. Some quantum foam or bulk space or high-dimensional substrate that our universe is embedded in. The multiverse theories suggest this. They propose that our universe is a bubble. A finite region of space-time floating in a larger something. And that larger something contains other bubbles. Other universes. Each with its own space, its own time, maybe even its own laws of physics. If that's true, then our universe does have an edge. But crossing that edge wouldn't take you into nothing. It would take you into a different kind of something. A between space. A cosmic ocean that our universe is just one island in. Except we can't test this. We can't see beyond our observable universe, let alone beyond the actual universe. It's speculation. Educated, mathematically consistent speculation. But speculation nonetheless. So where does that leave us? 3 possibilities. Infinite universe. Finite but curved. Finite with an edge. And we don't know which one is real. We know the observable universe is finite. We know it has a boundary, the cosmic horizon, beyond which light hasn't had time to reach us. We know the actual universe is at least as big as the observable universe. Probably much, much bigger. We know the universe is expanding. Not into anything. Just expanding. Space itself is growing. The distance between galaxies is increasing. Not because they're moving through space, but because the space between them is stretching. And we know that expansion is accelerating. Something called dark energy is pushing space apart faster and faster, which means the cosmic horizon is actually shrinking in a sense. Galaxies beyond a certain distance are receding from us faster than light can travel, which means we'll never see them. They're slipping beyond our cosmic horizon permanently. The universe is not only bigger than we can see, it's becoming more unreachable every second. But is it infinite? Is it curved? Does it have an edge? We don't know. And here's the thing that gets me. The thing I can't stop thinking about. Maybe those questions don't have answers. Not because we're not smart enough to find them, but because the questions themselves are wrong. Based on assumptions that don't apply. We assume the universe is a place. A big place, sure. But still a place. A thing with properties. With boundaries or lack thereof. With an inside and an outside. But what if the universe isn't a place? What if it's something stranger? A process, a mathematical structure, a wave function, a hologram projected from some lower dimensional boundary, a simulation running on substrate we can't access? What if where doesn't apply? What if asking where is the edge is like asking what does blue taste like? Category error. Wrong kind of question for the thing you're asking about. I don't know if that's true. But I know this. Every time we've thought we understood the universe, we've been wrong in interesting ways. We thought Earth was the center. Wrong. We thought the Milky Way was the whole universe. Wrong. We thought space was static. Wrong. We thought the expansion was slowing down. Wrong. We keep discovering that reality is weirder than we imagined. More subtle. More strange. So maybe the edge of the universe isn't a place we'll ever find. Maybe it's a concept that dissolves the closer we look at it. Maybe the question contains its own answer. There is no edge because edge implies something that doesn't exist when you're talking about everything. Or maybe there is an edge. And it's so far beyond anything we can observe or measure or even theorize about that it might as well not exist. Functionally infinite. Effectively boundless. Either way, you're here. On a planet orbiting an ordinary star in a galaxy containing hundreds of billions of stars. In a universe that might go on forever or might curve back on itself or might end at some unimaginable distance in some unimaginable way. And your problems, the ones that feel so big right now, so pressing, so overwhelming, they're happening in that context. Not to diminish them. They are real. They matter. But they're also local. Temporary. Contained within a cosmic structure so vast and strange that we can't even agree on whether it has edges. The Apollo 8 astronauts saw something in December 1968 that changed them. Changed all of us, really, though most people didn't realize it at the time. They saw Earth rising over the moon's horizon. A fragile blue marble suspended in absolute blackness. Small. Vulnerable. Alone. Bill Anders, who took the famous photograph, said later that they went to explore the moon and discovered Earth. That one image, Earthrise, did more for environmental awareness than decades of activism. Because it showed people, viscerally, that we live on an island. A finite world in an infinite ocean. But here's what strikes me about that moment. The infinity they saw wasn't really infinite. It was just very, very big darkness. The edge of the observable universe was out there, 4 to 6 billion light-years away in every direction. They couldn't see it. Nobody can. But it was there. A horizon beyond which information cannot reach us. Yet standing on the moon, looking at that blackness, it felt infinite. And in a way, that's what matters. Not the mathematical reality of the universe's geometry, but the experimental reality of being a small consciousness looking out into vastness. We talk about the universe like it's an object. Something we can point to and describe. But we're inside it. We're made of it. Trying to understand the universe from the inside is like trying to see your own face without a mirror. You can infer things, measure things, build models. But direct knowledge? That might be impossible. The ancient Greeks understood this better than we give them credit for. They didn't have telescopes or general relativity, but they asked the right questions. Archytas of Tarentum, a philosopher from the 4th century BC, posed a thought experiment. If you travel to the edge of the universe and throw a spear, what happens? If the spear flies forward, then there must be space beyond the edge, which means it wasn't really the edge. If the spear bounces back, then there's something there, a wall or barrier, which means the universe doesn't end, it just transitions into something else. Either way, the concept of an edge dissolves under scrutiny. Modern cosmology has basically formalized Archytas's spear into mathematics. We've replaced the spear with photons and the edge with cosmic horizons, but the logic is the same. Edges create paradoxes. Boundaries require something to bound against. Unless the boundary is geometric rather than physical. unless space curves in on itself. Unless we're living on the surface of a hypersphere, and edge is the wrong word entirely. Einstein's field equations allow for this. They describe spacetime as a fabric that can bend, stretch, and fold. In some solutions to those equations, the universe is closed. Finite volume. No edge. Like the surface of a balloon, but in 3 dimensions instead of 2. In other solutions, the universe is open. Infinite. Saddle-shaped. Extending forever. And in still others, the ones that match our current observations, the universe is flat. Perfectly balanced between open and closed. Which, mathematically, suggests infinite extent. But not necessarily. You could have a flat geometry that's finite if you invoke the right topological tricks. A flat torus, for instance. Video game wraparound physics applied to the cosmos. The universe could be shaped like a Pac-Man screen. Travel far enough in one direction and you emerge from the opposite side. No edge. Finite space. Flat geometry. All consistent with the data. We have no evidence for this. But we have no evidence against it either. The observable universe is too small compared to the wavelengths we'd need to detect such topology. It's like trying to determine the shape of the Earth by examining a square inch of ground. You can tell it's relatively flat, but you can't tell if it's a plane or a sphere. So we're stuck with possibilities. With models that fit the data but extend beyond what we can verify. And that's unusual for physics. Usually we can test things, build experiments, make predictions and check them against reality. But the edge of the universe? If it exists, it's untestable. By definition. We can't go there. We can't see it. We can't even send a signal that would reach it in any meaningful time frame. The observable universe is expanding at the speed of light. The actual universe, if it's finite, is expanding too, but we don't know how fast because we can't see its edges. And even if we could somehow travel at the speed of light, we'd never catch up to the expansion. We'd be running on a treadmill, making no progress toward any hypothetical boundary. The edge, if it exists, is permanently out of reach. Not just practically. Fundamentally. Which makes me wonder, does it matter? If we can never observe something, never interact with it, never be affected by it in any measurable way, does it exist in any meaningful sense? Philosophers call this kind of question metaphysics. Scientists usually avoid it. But in cosmology, you can't avoid it. The edge of the universe is inherently metaphysical. It's a question about what exists beyond all possible observation. And different scientists have different tolerance for that kind of question. Some say, if we can't test it, it's not science. It's philosophy. Maybe interesting, but not our domain. Others say, the universe doesn't care what we can test. It is what it is. Our job is to figure out what that is, even if we can never verify it directly. Both positions are reasonable. Both are frustrating. Because the truth is, we want to know. We want to know if there's an edge. We want to know what's beyond it. We want to know if the universe is infinite or finite, open or closed, alone or part of a multiverse. We want answers to questions that might not have answers. At least not answers we can access. There's a scene in the Flatland Thought Experiment, a novella written in 1884 by Edwin Abbott Abbott. Yes, that's his real name, where a two-dimensional being encounters a three-dimensional sphere. The sphere passes through Flatland, and from the two-dimensional perspective, it appears first as a point, then as a growing circle, then as a shrinking circle, then as a point again, then it vanishes. The Flatlander can't comprehend what's happening. Can't visualize a sphere because they only experience 2 dimensions. They can observe the effects, the changing circle, but they can't grasp the underlying reality. We might be in the same position with the universe. We observe 3 spatial dimensions. We detect effects, expansion, curvature, cosmic horizons. But the underlying structure? The higher dimensional reality that our three-dimensional slice is embedded in, we might be missing it entirely. Not because we're not smart enough. Because we're not dimensional enough. String theory suggests there are 10 or 11 dimensions, most of them curled up so small we can't detect them. What if one of those dimensions isn't curled? What if it's large, and our universe is a three-dimensional membrane floating in a higher dimensional bulk? In that model, the edge of the universe would be the edge of our membrane. Beyond it would be bulk space. Maybe other membranes. Other universes. We couldn't see them. Light can't travel through bulk space, only along our membrane. But gravity might leak through, which could explain dark matter, the invisible mass that seems to be everywhere but doesn't interact with light. Maybe it's matter on a nearby membrane, close enough in bulk space that its gravity affects us. Pure speculation. But mathematically consistent speculation. The equations work. They make predictions. Some of those predictions might even be testable, though we haven't tested them yet. And that's where cosmology lives now. On the edge of testability. Playing with ideas that might be right but might be forever unverifiable. It's an uncomfortable place. Science is supposed to be empirical. Grounded in observation. But when you're asking questions about everything that exists, about structures larger than the observable universe, about dimensions we can't access, empiricism runs out of road. You're left with mathematics. With consistency. With models that fit what we can see and extrapolate beyond it. Is that still science? Or is it something else? Something between science and philosophy? I think it's both. And I think that's okay. Because the alternative is to stop asking. To say we can only know what we can observe, so we won't think about the rest. And that's not how humans work. We've never been content with that. We've always looked at horizons and wondered what's beyond them. Always pushed against boundaries. Always asked, what if? The edge of the universe is just the ultimate horizon. The final boundary. The last what if. And maybe we'll never know the answer. Maybe the universe will keep its secrets. Maybe the edge, whether it exists or not, will remain beyond our reach forever. But we'll keep asking. Keep building better telescopes. Keep refining our equations. Keep searching for patterns in the cosmic microwave background that might reveal the shape of space on scales larger than we've measured. Because that's what we do. That's what consciousness does. It reaches beyond itself. It grasps for understanding even when understanding seems impossible. The universe made us capable of asking questions it might not let us answer. And I don't know if that's cruel or beautiful. Probably both. You're lying here, listening to this, thinking about edges and infinities and dimensions you can't visualize. Your brain, 3 pounds of organized matter, is contemplating the structure of everything that exists. That's absurd. Wonderful. Impossible. And yet here we are, doing it anyway. The edge of the universe might be 4 to 6 billion light-years away, or infinite, or a geometric loop, or a membrane boundary in higher dimensional space. But the edge of your understanding, that's right here. Right now. Bumping against the limits of what human cognition can grasp. And that's its own kind of horizon. Its own kind of boundary. Maybe learning to sit with that, with not knowing, with mystery, with questions that exceed answers. Maybe that's the real discovery. Not where the edge is, but what it feels like to reach toward it anyway.